Hello everyone. Today we're going to talk about redelivery of messages in MuleSoft when something fails in your flow. And while redelivery on itself is not that much difficult in MuleSoft and it's supported in multiple components, redelivery with an exponential backoff, which we're going to cover today, is is not that straightforward. There are several use cases, right? So, for example, you can do it with until successful when the traffic is low or when the traffic is high, you have lots of messages. Then you will want to do it in an async way with queues. And we're going to cover ActiveMQ and how to do that with ActiveMQ today, especially with ActiveMQ Artemis, which is difficult from Classic. And it just takes time to put all the configurations together and to show how it works. So I hope in this video, right, it will give you an impulse on where to start with your redelivery journey with an exponential backoff. All right, so let's start with a simple use case. I have a setup with 3 flows, which will highlight the redelivery with until successful, the redelivery with queues, kind of a self-made one. And right in the last example, we will totally rely on ActiveMQ to do the work for us. And let's see how all that works. As a basic idea, I'll be sending messages to Postman Echo, right, where I can control if I'm sending something like status 200, so Postman Echo will respond to me with 200. If I'm sending like 502, it will respond with 502, and the HTTP request operation will treat that as an error. Right. When we are planning to use redelivery, we have to differentiate between a transient error and a permanent error. So a transient error is when something is temporarily wrong with the network. For example, a service is returning you 502, which means something's wrong probably with the gateway or like a proxy is misbehaving. And this is kind of error which you can retry. If you are getting back HTTP 500 or 400, retrying will not fix it. Although 500 is, we can discuss it, but 400, meaning your payload is wrong, unless you fix your payload, retrying makes no sense, right? So retrying makes sense when an error is transient, meaning it's temporary, and retrying has also different use cases. Let's say that you're receiving not that many messages, right? The traffic to your flow is quite low or very low. Maybe it's just several messages per day, or maybe it's one after another, or maybe you have multiple threads and then it's just a little bit, so not that much. In that case, you can use like in a default Mule configuration. So right, you would use until successful, and let's look at it. So in until successful, right, you can have how many times would you like to retry your operation and what's the delay between them, but you don't have the exponential backoff. So exponential backoff means that the time between the retries is increasing exponentially depending on the number of the retries, right? So for example, first retry after 1 second, second retry after maybe 3 seconds, third retry after 9 seconds, and so on. So MuleSoft doesn't have it right in its toolbox per default, but luckily we have a hero. His name is Roger from CodeCentric, and he open sourced his own element, repeat until successful, which supports the exponential backoff and also supports kind of different. You can differentiate in the component whether your error is transient or not, and if it's not transient, then it will stop retrying directly. It will not even attempt to retry. If the error is transient, it will retry. So we'll see how it works. And right, I first need to start my setup. Since we're gonna also demo ActiveMQ, need it for my flows. I have a pre-configured Docker container with ActiveMQ. Start it locally. We will also use it for the second and third part of today's demos. Okay, so ActiveMQ is starting. While it's starting, let's also start our flows. And what we're going to do now, we're going to send like a successful operation first to this 8083 port, which will be forwarded to Postman. And right, successful should just go through, and then we'll simulate an error, and we will see how the error will retry. And let's see how many times we'll retry. So we will retry 3 times with initial delay of 1 second, and then each consecutive retry will be increased times 3. So 1 second, 3 seconds, 9 seconds. We'll not see fail fast, but it's working. So we'll just see the retries. The flows are started. Let's clear that. So, right. So port 883. First, we're going to do a successful attempt. Let's just start with 200. As we can see, the request landed here. These are just the log messages. So it was about to start sending, and then the request was sent. That's this log message and the last one, and then this request succeeded. So now we're gonna make echo respond with 502, so HTTP 502 status. And as we know, the HTTP request operation treats 502 as an error response, meaning it will throw an error here, and the repeat until successful will catch it and will retry the operation. Let's see that it's doing that. So, right, we can see it's retrying. So this is the original attempt, the first one, then first retry, second retry, and you see the time between the attempts is increasing. The last retry was actually, let's see, it should be 139 seconds. So this is the last one. As we can see the time between these two is almost 9. Well, it's 9. I won't calculate it. Right here we have 3 seconds, and right, and this is this should be so after this between these two, it should be 1 second. Well, it's kind of yeah. Right, and then when all the retry attempts are exhausted, the repeat until successful element will rethrow the original error, and as we can see, Postman responded with 502. So this is a very straightforward and very easy way to implement a redelivery of the messages with an exponential backoff with a kind of repeat until successful way, as we know it in MuleSoft. And the component is very lightweight, so really recommended if this is what you need, if your traffic, so if there is really a low amount of messages coming and you can afford yourself to block a thread because both uh, until successful, the original one and this one, they will block a thread. So if you can allow this, use it. It's totally valid. Right. But let's say that in your setup, you are getting lots of messages and you cannot allow yourself to block a thread. So in this case, you would want to do redelivery based on the queues. And so how to do that? Oh, so obviously for the redelivery, right? So for handling the backoff and in calculating the exponential backoff, you need some kind of storage, right? So you need a state, and the state has to be persisted somewhere. And with queues like ActiveMQ, so message brokers like ActiveMQ or RabbitMQ, they basically do support redelivery. The only difficult thing is to figure out how exactly to configure it. So in our case today, I will use ActiveMQ, not the classic one, but the Artemis, so the latest one, which is supposed to be more performant, and configuring redelivery with it is tricky. So first we're gonna kind of play with the redelivery and do it almost manually, and we'll see like the basics, the principles. So my ActiveMQ is running, as we can see. I can even log into it. Right, I have some queues, but let's see what we do here. So how our setup looks like. So we will send a request to HTTP 881, and then we will directly start and call the HTTP operation towards Postman echo, right? So this flow reference will go here, we'll trigger the request to Postman, echo. If it's successful, we'll just log it. If it's not successful, so for example, HTTP 502, right, we will go into error handling and we will kind of, switch the, so it will be like HTTP async mode. So we will switch to an async mode where instead of responding directly with a post echo response, we'll just put HTTP 202, your message is accepted, right? We'll take care of processing it. This is just for the demo purposes of redelivery, right? Don't catch me on the business logic. It makes no sense here, but right, we just want to test the redelivery. So if an error occurs here, we'll dive into a publish for a retry. So we will use a queue. We will publish our payload into that queue, and we will calculate which attempt is that when we are publishing into the queue. And when publishing into the queue, we will also use the functionality of ActiveMQ, where we are able to tell it. So it's a scheduled delivery. We are able to tell ActiveMQ when to deliver our message back to us from the broker. So the message will sit on the broker. The broker has a schedule itself. And when the time comes, the message will be pushed back to this flow. So let's see how it's configured. Let's first see the publish operation. So the redelivery on ActiveMQ is supported if you're using JMS 2.0, the 2.0 specification, right? There is also 1.1, which is the default. If you're using it, you cannot send the redelivery property to the JMS to the ActiveMQ, to the JMS broker, to the JMS message broker. So we have to configure a connection to ActiveMQ using the JMS2 specification, right? It's also relatively straightforward. You just configure it, right? And we will use the Artemis client here, and right, so just username, password, where's the broker, and what's the client. So it takes time to put all these configurations together, but the good thing, you can just have it. I'll put it on a GitHub repository. Right, so basically that's it here. There is no more magic. And once we have the JMS2 specification configured, we will be able to do things like this here. So look at it. So first we will also put our own property, which attempt that is, and that's in order to calculate the next delivery. And since we will control the attempt, the number of attempt on our side, we will also be able to calculate the next delivery time, and we'll do that. And here is the interesting thing. So in Mule 4, the GMS publish configuration contains a delivery delay, which you're able to use when you use GMS2, right? And we will calculate the delivery delay in milliseconds. And so this is actually, right, that's the delay, right? And then the API specification itself will calculate when the message should be scheduled on. So how we do this? Here we go in and say, right, so this property will be set by the ActiveMQ when the message is being pushed to us. So when we consume the message, if it's there, cool. If it's not, we say we start with with 1. So right, this is our first redelivery attempt. We'll store it in the attempt variable. Then we go on and say if, right, if this is like first or second or third attempt, then go and kind of schedule the next redelivery attempt. So we will calculate the backoff time by using a small data function, which is receiving the number of attempts, the initial delay, and the exponent, the factor, how the initial delay will be multiplied. The function is really simple. Let's look at it. It's not doing much, just multiplies everything. And right, so we have our attempt. Which attempt is it? Based on the attempt, we calculate the delivery delay. With the attempt and delivery delay, we publish a message to an ActiveMQ, right? It's saying here, this is our attempt number, and this is the delay, right? And then the message is published. If we've exhausted our attempts, right? If it's like the fourth attempt, we will just say, all right, we failed completely, so finish here. And so then what will happen when this redelivery message is being popped back to us? So these on new message source will listen to our queue, right? So we publish to the same queue, Backoff queue, right? Here also Backoff queue. So we listen to that queue. We almost do nothing here. The only important thing, oh, actually there is no, the only important thing will be will be later. So we immediately acknowledge that okay, we've read the message from the queue, and that's basically it. So we just take the payload, log it, and go and resend. So send postman echo, that's this one, and go and resend to postman. Here again, either it succeeds or it fails. If it fails, it goes here, schedules the next retry, right? Increases the attempt, calculates the new delivery with the increased attempt, publishes a message, then it pops back to us, right, when the time comes, and then it retries again until we've exhausted our attempts. So, right, I hope that's this is just a demo setup to show how it works. I mean, right, it could be developed differently, but for the sake of it, let's just test it. We go to port 1. Let's first send a successful message, see that it works, right? And that was easy. We also, so in this case, right, we also received directly the response from Postman. So this is status 200, right? As we can see, request sent successfully, meaning this worked and this worked as well. So now let's go and try 502. And right, so now I will expect 3 redelivery attempts with an exponential backoff. Let's see what it does. Let's go to console, and here we go. Right, so let's look at the logs. Now it could be fast, but so what happened right now? All right, and then it finally failed. So let's see what it did. So this is the first attempt to send the message. And let's look at the logs, request. Right, so this is the first attempt to send the message to Postman. It failed. After it failed, right, we say transient error, oops, sorry, transient error occurred, set for delivery in 2 milliseconds, so 200 milliseconds, which is 2 seconds. Then after 2 seconds, the message is getting back to us. This is our first delivery attempt. And then it fails, right? We could also see, so these are the 2 seconds delay. Then this attempt fails, the backoff time increases, been scheduled for a delivery. And then here's the next attempt. And as we can see, it is now, well, it's supposed to be 4 seconds. And it fails again, right? Then again. So now it increases, the delay increases to 8 seconds. And as we can see here, after 8 seconds, this is the third and last redelivery attempt. And then we are saying, okay, we are done. After you've exhausted all your delivery attempts, right, the next logical step is to put the message, the failing message, into the dead letter queue. And then, later on, you just process and make and handle your dead letter queue appropriately. So this is right. This is kind of half manual setup using ActiveMQ, or actually any JMS 2.0 spec supporting message broker. So RabbitMQ will work as well, ActiveMQ, or there are more. So this kind of manual setup is, I would say, message broker independent, if you want, would work almost everywhere. So with anything which supports GMS2. Right. Let's go and see the fanciest example. So this one looks simpler, and in this case, we will rely absolutely on the ActiveMQ redelivery mechanism. So no work almost done in MuleSoft, but all the redelivery logic and the exponential backoff logic in this case is handled by the ActiveMQ. Right. So how do we do that? Here is a trick. So if you look at if you search in internet for all the manuals how to configure the redelivery with an exponential backoff, most of the examples that you will find will tell you that when you configure a connection to an ActiveMQ, you have to specify the redelivery and the exponential backoff, and it will work if you're using ActiveMQ Classic. If you're using ActiveMQ Artemis, it will not work. The redelivery is being configured on the broker, not on the connection, so not on the client side, but in Artemis, they've changed the concept, and now the redelivery for a queue is being configured on the broker, meaning you're expected to either adjust your broker XML configuration file in your ActiveMQ instance, or it's dynamic, so it could be controlled via a JMX interface, for example. Let's say if you have ActiveMQ Artemis running somewhere by using JMX, you can add an address configuration, and so address relates to queue, so to say, and then you tell that queue to support redelivery. We will see how it goes. So I've already started my ActiveMQ, but let's have a look how I configured it. So the magic here will be in having this broker XML file. And so I took the original broker XML from the ActiveMQ Artemis and added this. So this address setting is saying that if the message, so if the queue which I'm publishing to is matching this name, exponential backup queue, and we will see I will be using this name, then initial redelivery delay in case of error is 5 seconds. We will have 4 attempts. 4 here is, I just built the use case like this. So the first, you will see the first attempt will be the original one, and 3 more will be the retries actually. Right, the multiplier for the attempts is 2, meaning 5 seconds, 10 seconds, actually 20 seconds. But we say max redelivery delay could be only 15 seconds, so 20 will be cut to 15. It's just to play with it. Right, and then when the redelivery attempts are exhausted, the message should be put into dead letter queue, DLQ, which is defined before. Right, so this is the dead letter queue. Sorry. Yep. All right, so let's see how that works. Oh, sorry. So this file, this broker XML, if you see again how I started my ActiveMQ broker, I mapped a folder where this file exists. So this broker folder has this broker XML file. You need to map it to Artemis instance etc override. This will tell Artemis to map, like to override its configuration as you can see here. So it will override its configuration with this broker XML file. Once this is done, this queue, is it? Right, so this queue will support redelivery automatically. Then you won't need to do anything in Mule almost. Right, so let's go back to our setup. So in this case, what we'll do with the payload, we'll listen on 8082 and we'll go async directly. We won't even try initially to talk to Postman Echo, but we'll directly push the payload to the queue, and then the queue will, retry, right? And we'll say, okay, so we are going to HTTP async 202, your message accepted will be processed. So once we publish, and here the like standard publish operation, we are publishing to the queue where we configured the redelivery for the exponential backoff queue, using correlation ID, etc. The rest of the configuration is fairly standard, so I haven't changed anything. As you can see, no delivery delay, no nothing, just connecting to ActiveMQ. That's it. And the fancy stuff is happening here. So on a new message, now that we want to use the redelivery mechanism of ActiveMQ, we have to say it when the delivery, so when the delivery is good and when it's bad. And so what I did here, I configured acknowledge mode manual, meaning I will tell the message broker when processing the message has succeeded. This is this acknowledge operation. And another important thing to configure here, if you want the redelivery mechanism to kick in, you need to use transactions. So you need to start a local transaction in this case, right? So that's what we do here. We always begin a transaction. It's local, meaning not distributed. And when within the local transaction an exception or an error is being thrown, this is telling the message broker to roll back. So it's telling the message broker that, yeah, the message processing has failed, and then, do whatever you do. In our case, the message broker will redeliver and will redeliver with a configured exponential backoff. And what we do here, so on a new message, we'll log saying, hey, the message has been redelivered, or actually in the first case, in the first time it will be delivered, then it will be redelivered. We'll send it to Postman. Everything's good. Message is consumed. If an error is happening here, an exception like an error is thrown, we are going to error handling. In error handling, we'll just log, something failed. We'll propagate the error further, right? With that will kick in the rollback for the message broker, and message broker will redeliver. Right, so let's see what we do here, right? So this send is just sending the request to Postman as before, and that's basically it. So by relying on ActiveMQ's native redelivery mechanism, we are not handling that logic, right? So we just need to use transaction and either complete the transaction or throw an error within the transaction. So let's see how this one works. Let's go to console here. So 8082, right, as usual, let's start with a happy case. So in this case, we send the request, right? So we go here. The payload is being pushed to the queue for the delivery or a delivery in that case. It directly is being consumed, logged, sent to Postman, acknowledged. Everything is good. So let's see. Lots of unneeded messages, but basically a request is being sent to Postman. And this is an attempt number 1. So, right, first attempt, straight to Postman, everything's good, nothing's happening. Now, let's clear that. Now let's say there's a transient error, right? We send the request. We will see here, all right, so it failed on the first attempt of delivery. Then there is a second one. Now we're waiting a little bit more, 10 seconds if I'm correct. Now there is another attempt, and after 15 seconds, right, that was our cut. So in 15 seconds there should be a last attempt. See that? Right, this is the last one. And then we say redelivery failed completely. And we can also see in the log of the ActiveMQ that it will send the message to the configured dead letter queue. So we are exhausted all our redelivery attempts. The message is being sent by the ActiveMQ itself, right? Because we configured it here to do that. Right, and so here's the thingy. This is the last 15 seconds delay between the attempts. This is the 10 seconds delay between the attempts. And here is the 5, right? So knowing this, knowing where to configure this in ActiveMQ Artemis, it's fairly straightforward to use it for a delivery. Or if you need like a more control over your redelivery and but while still using exponential backoff, you can do a construct like this. Then, right, yes, more elements, more complex logic, but you control everything. If you have really low traffic and you are like it's okay for you to block a thread, then just use a fairly simple repeat until successful with an exponential backoff. So these are like three main examples I wanted to show. I hope that helps and gives some, impulses what to do whenever you need to guarantee delivery of messages and for your delivery you would like to use an exponential backoff and don't know where to start. Enjoy.